In 5.2.2, we're going to continue to talk about the normal distribution, but we're going to begin to add a little bit more in terms of calculator commands. In the last section, we talked about this command right here, the normal CDF. And remember that command was specifically to help us find an area under a curve, or specifically then a probability, could be represented by a value of p. So it's again super important to keep in mind that this command here will find for us a probability. And so we saw in the last section a little bit of how to do that, and we'll continue to do that sort of question in this section. However, we're also going to see that in this section we're going to learn about this new command referred to as the inverse normal command. And we'll see that this value, or this calculator command, will ultimately be responsible for returning a value of x. That is, it will find a number that exists on our horizontal number line. So let's see kind of how this works as we take a look at example number 1. So the amounts a soft drink machine is designed to dispense for each drink are normally distributed, with a mean of 12 fluid ounces and a standard deviation of 0.2. So you can maybe kind of imagine this, I don't know, maybe you've driven through like a McDonald's drive-through at some point, right? And, you know, when you're getting ready to grab your food, there's not much to do. So you might, try to glance inside through the window and you might see that drink machine, right? And typically they have some different buttons on there. Maybe you can select you select the button on there that fills up like a large, and then the machine, over here starts like dispensing a bunch of liquid into the actual cup that the person's, put under it. So click the button, the thing starts to fill up with liquid, and this liquid that it's actually spitting out, it might vary slightly from drink to drink, right? It's not always maybe going to spit out exactly the same. You might be able to expect that maybe there's like a drop or two more occurring in certain types of on certain pushes of this button. Well, if we suppose that there's an average of 12 fluid ounces that spits out, and the standard deviation is 0.2, then we could start to go ahead and think about a couple different things here. Now, first off, you'll see again that I have this space that's listed here, or given here, and we want to go ahead and fill that in as we start to think through what we understand from our formula sheet. Remember that on the formula sheet again we have this nice flow chart, and if we're working with a normal distribution, then we are going to be working with this third column that we have over here. And of course we're going to start at the top and work our way down. So I'm going to start by identifying and stating what my random variable of x actually is. So in this case I could say, let's let x represent the amount of ounces in a soft drink, right? Like I don't know how much liquid is actually going to end up in the cup. That's kind of what's in question right now. Now, if I follow the formula sheet down to the next thing, I can see that it's going to ask me, what type of distribution do you have? Well, if we think we're in this column, it should be normal. But again, how do we know that? How do we check that? Well, we have two ways of doing that. One, the problem should just say so, or actually in the next section, we'll talk about how we can use raw data to construct a special type of plot or graph to help us understand if we think that a distribution might be normal. In this case, though, the problem actually just directly says that we have a normal distribution. After, of course, we're able to state this, we want to be able to state what the mean and standard deviation are before we ever touch our calculator. So I'm going to go ahead and continue to write this down. X has a normal distribution with a mean for x being 12 and a standard deviation for x being 0.2. Again, without writing this information down first, it would actually be really detrimental to start jumping into part A. In fact, on exams in this class, I will often ask you to demonstrate that you can do all of this work up here in certain questions. I might actually say, hey, can you define what the random variable is, tell me its distribution, and state its parameters? It's a very common thing I like to ask. Well, let's take a look now at part A. Could I now find the probability that the drink is going to have less than 11.9 ounces in it? Okay, so I have some ways to try to think about this, and we saw that in the last section it was very helpful to try to go ahead and oftentimes just draw out a quick picture. I know I have a normal distribution, so I'm going to draw a normal curve. I know the mean is going to be 12, and the standard deviation is going to be 0.2. So I'm interested in a drink that has less than 11.9 ounces. So let's say 11.9 is right here on the number line. And I'm going to go ahead and draw or shade less than that. And again, I'm interested in finding the probability. So I want to know how much shaded space is there. And so when I go back and I look at my calculator commands, remember that normal CDF is always the command that finds you a probability, that finds you an amount of shaded space. So that's the purpose of normal CDF. It will get you this shaded space. So that's the calculator command I would use, just like we did in the last section. So I would go ahead here and I would write, I want the probability that X, the amount of ounces in the soft drink, is less than 11.9. I know I can set that up with a normal CDF. Remember, my first two values are where my blue region starts and stops. Well, on the left side here, I can see that my region goes down towards negative infinity, down towards negative forever. And so since I can't type that in, we instead, in the last section, said we would use a very large negative number that we would express with negative 1 E99. Then I would go up to 11.9, and then I would state my mean and my standard deviation. Now I can go to my calculator and actually figure out what that percentage actually is. So once here, I can go ahead and click second, vars. Then I'll do normal CDF. I'm going to click negative 1 E99. I'll go all the way up to 11.9, 12, and 0.2. And so this is what I have written down on the page, also what I have typed into the calculator. And I go ahead and hit enter. So I get 0.3085. So I'll go ahead, go back here, and I have 0.3085. Okay, so keep in mind again, that is the amount of blue space. That's what we found. We can now update what we have here. The amount of blue space in the picture is 0.3085, or a 30.85%. Okay, great. So this is a question like what we saw in the last section. Not much has changed, and we haven't used this new calculator command yet. But let's take a look at part B to see what this question asks. What number of fluid ounces will have roughly 30.85% of all other amounts of fluid ounces below it? Okay, first off, that's a very strange sounding question. But one thing that I should notice is this question is not asking me to find a probability. What it's asking me to find is a number of fluid ounces. So I am not interested in an amount of shaded space. I actually am interested in determining a value of X. That is, I want to know an X that occurs on this number line. Now, the rest of the information here is just trying to help me understand where this X might be located on the number line. So let me go ahead and actually draw out again another normal distribution to help me try to think through this. So I still know I'm talking about the soft drinks, has an average of 12 and a standard deviation of 0.2. Now I know that my green X will have roughly 30.85% of all other X's below it. So I could start to think about where in the world my X could be located on the number line. If I go below it, there should be about 30.85%. Well, if I think about that, doesn't that mean my X value has to be somewhere over here on the left side of 12? So that way when I shade below it, I'm going to get some value that might be 30.85%. Obviously, I couldn't select my value of X to be on the right side of 12 because then when I shade below it, I'm going to shade more than half of the space. I would get something like then over 50%. So I'm going to need some space down here. Now, the interesting thing right now is that I already know the amount of space that I need. I need this percentage, or what could be written as 0.3085 if I converted that percentage just to a nice decimal representation. So the question then is, what in the world is a value of X that could do this? Well, if you're looking at the problem up above, it might not be too cryptic. We already kind of know what this value of x should be, right? Isn't it just going to be 11.9? That's exactly what it should be. But how would I find that value of 11.9 if I didn't already have a part A completed? Well, this is where this new calculator command of inverse normal can help us. Inverse normal is going to help us find an x on a number line, but it's going to have three different inputs. Notice the inputs that I have here. Their first input is going to be the area, or the probability, to the left side of x. I need the area on the left side of the x I'm trying to find. The second input is going to be the average for the curve, and the third one is going to be the standard deviation. So notice here I'm looking for this x, and I want to ask first, for my first input, how much area is on its left side. You always have to go to the left side. Well, notice I already have that number. That's my number in blue. So that's this value. My next value would just be my mean and my standard deviation. Notice that if I go to my calculator now and I try to go ahead and actually evaluate this, I can see that I'm going to click second and the vars button again. Option number 3 should have inverse normal. And notice it's going to ask area to the left, so 0.3085. The mean was 12 and the standard deviation was 0.2. This is what I have written down on the page. It's also what I'm typing in. And notice that I get 11.89997. So again, that 7 is going to have to round up. But here you can see I have like 8,999. And if I round that all up, that's just going to be 9,000 or 9000. So my final answer does end up being 11.9000 ounces. So I found exactly what this green value is in the picture. It's that number of ounces. So this is the important thing that we should be able to distinguish between these two calculator commands. They compute very different things. Normal CDF finds you the amount of space, whereas inverse normal will find you the x on the number line that might help to determine a particular amount of space to the left. We'll take a look then really quickly at part C. We'll just try one more of these. What number of fluid ounces will have roughly 40% of all other amounts above it? So again, I should notice I'm still looking for a number of fluid ounces. But let's go ahead and still draw our picture to help try to think through this. Okay, so I have a little number line written out. I draw out a little normal distribution. I know I still have 12 and a standard deviation of 0.2. Now, this value of x, my new green x on this problem, will have roughly 40% of all other amounts of fluid ounces above it. So can I put my x on the left side of 12? Well, if my x was over here on the left side somewhere, then when I shade above it, I would definitely get way more than half of the shaded area, or half of the total area under the curve. And I don't want that. I only want 40%. So maybe my x value is going to be like right here. So that way, when I shade above it, I'm going to end up with the amount of space that's here being 40%, or 0.40. Okay, so how can I find that x? What calculator command can I use? I can use the command of inverse normal. That's what the inverse normal command does. It finds you a mystery x on the number line. But remember, I had 3 inputs here, and the first input is the one that people often mess up. A lot of times people will come here and they'll just write that blue 40% as their starting percentage, and that's definitely going to be wrong. Because, as we see up above in the box, I should insert the area or the probability that is to the left of the value of x that I'm looking for. So while I have 40% over here, I'm going to be interested in how much extra total space is actually going to exist in this portion. Well, if there's 40% over here, and the total area under the curve always has to be 100%, then to the left there would have to be 60%. And then I would go ahead and do my mean and my standard deviation. I can go to my calculator to try to type this in. Let's see, I'm going to go down to option 3. And I'm just going to change that area to be 0.60. Now that I have this as 0.60 in there, I can go ahead and hit enter, and boom, I get a number 12.0506. All right, so I'll go ahead and write that down. Oh, I guess 07 if I round 4 places. So I have 12.0507 ounces. And again, I found that green value that's on the number line. Of course, this value should make sense, that it should be a number that was larger than 12 if this is where it was positioned. You might notice if you went back and computed this same thing in here with a 40%, you would have gotten a number that would have been like 11 point something. It would have been a number over here, and then we could have definitely told or determined from that we would have calculated something incorrectly. Our value of x being over here means it's to the right of 12 on the number line. It must be larger. Hopefully this gives you a good sense of what these two calculator commands are good for, and in the next video we'll take a look at a couple different examples of how we can use this to compute and answer a whole bunch of other sorts of questions.